Alright everyone, in this video we are going to learn about volcanoes, and I would like to take this opportunity to introduce you to one of the most famous volcanoes on earth, which is called Mount Anak Krakatau, which is located in Indonesia. And I think there will be a few slides talking about Mount Anak Krakatau later on, so stay tuned. And so these are all the things that we are going to talk about and go over. The first one is I'm going to introduce you very briefly about volcanoes, and then I will talk about styles of eruptions and its controlling factors. And in the next in the next videos, we are going to cover the rest of it. All right. So, introduction. Well, first of all, there are more than 1,500 active volcanoes on Earth, so there's a lot of them, and they erupted in the past 600 years. And in average, there has been 50 eruptions per year. Okay, and most active volcanoes that are located on Earth are distributed along major plate boundaries, which is called the Ring of Fire, and the Ring of Fire is located in the perimeter of the Pacific Ocean. And later on, you will also learn about the types of volcanoes. And the reason why we need to learn about this is because the risk and the hazards associated with the volcanic eruptions, they actually really depend on the types of volcanoes that we are dealing with. Okay. And this is also another thing that I would like to point out is that there are lots of people that live near volcanoes, and there's actually about 100,000 deaths during the last 125 years. Okay, and most of these happens in densely populated countries in volcanic zones, and those countries include Indonesia, Japan, or Mexico, just to name a few. All right, so what is a volcano? Volcano is a mountain that consists of repeated lava and or pyroclastic flows. Okay, I'm pretty sure at this point you should know what lava is all about, but we haven't really talked about pyroclastic flows yet. So there will be a specific slide that will talk about pyroclastic flows later on, so stay tuned about that. But I just want to let you know about this illustration, which is something that I think I already showed you in the when we learn about igneous rocks. But however, this illustration shows that we have layers of rocks right here, right? And these layers of rocks, they represent volcanic materials, and again, they can be either lava or pyroclastic materials. So what are pyroclastic materials? Just to mention about it, or just to explain it very briefly, this is what we mean by pyroclastic material right here. And that would include the ash cloud right here, as well as the ash flow on the side of the volcano. So all of these clouds, which in fact it's actually a mixture of many things: ash, rocks, gases, and many things really, but they will be considered as pyroclastic materials. So again, volcanoes are just a buildup consisting of, again, either lava or pyroclastic flows. All right, let's go ahead and talk about eruption styles. There are two eruption styles that I would like to focus in this course. If you are interested in learning more about volcanoes, there's actually a lot more detailed classification of eruption styles of volcanoes. But again, for this course, I would like to make it quite simple. So I want you to know that we have explosive style, and the second one is called the effusive style. And here are some pictures that kind of explain the eruption styles here. The explosive one, look at that. It looks very, very violent right here, where you have fires, ash, hot ash, and plume of smoke right here, right? And then you also have a fusive one that doesn't have that actually. In fact, it mostly involves some lava flow. Look at this, right? This lava flow. All right, so what are the differences between the two eruption styles that I already mentioned before. For explosive style, again, it is violent eruption of volcanoes, and these volcanoes typically produce hot gas and ash as part of this convective plume that you see here in this picture on the left. And the second one is called the effusive style, and this style is the non-violent eruption style. And again, it does not have any explosion, but it does have some materials coming out from the ground, and but most of it is magma or lava that reaches the surface and then it just flows on the ground like this. Okay, so there you go. That is the main difference between the two eruption styles. Right, so eruption styles. So in order to learn about eruption styles, it is so important to learn about the concept of magma viscosity. Okay, um, and there are actually three main factors that could influence magma viscosity. The first one is the composition of magma, the second one is the temperature of magma, and the last one is the amount of dissolved gas or volatiles within the magma. Okay, and again, these factors control the viscosity of a given magma, which in turn controls the eruptive styles of a volcano. And just to quickly remind everybody here that when I say composition of magma, this is what I mean by that. Okay, remember that we already learned about the different types of magma based on its composition, and it goes from ultramafic magma, mafic magma, intermediate to felsic magma. And again, if you notice that it really depends on the amount of silica content within the magma. As you go from ultramafic to felsic, you will have lower, the silica will decrease. Okay, the silica content within the magma decreases. So therefore, ultramafic has the lowest amount of silica, whereas felsic has the highest amount of silica. Excuse me. Okay, so what is magma viscosity? Viscosity is a measure of material's resistance to flow, and you might want to remember the stickiness of a fluid or of a liquid. Okay, so remember the stickiness or the thickness of a liquid. Okay, so higher viscosity means it is hard to flow, whereas lower viscosity means it is easy to flow. Okay, so for example, I have a picture of liquid within a tube here. Let's name it tubes 1 here on the left, and then all the way to tubes 5 here on the right side. So I want you to pause this video really quick and just try to guess which tube that has the highest viscosity. So pause it right now. I'm not pausing, but you should pause it. But anyway, so you should know that tube number 5, which is the right tube right here, all right, this is the one that contains liquid with the highest viscosity. Okay, whereas the lowest viscosity liquid is in this tube number 1 right here. Okay, because again, higher viscosity means it's hard to flow, lower viscosity means it's easy to flow. Okay, now as I mentioned before, that temperature is one of the factors that control the viscosity of magma. It actually happens like this. So hotter magmas are less viscous and easy to flow. Okay, so if you want to remember something, maybe you can, try to imagine if you have a glass of honey. Okay, one of them you basically heat it up on a stove, and then the other one you just put it on a freezer or on your fridge, for example, and then after several hours you compare the stickiness or the thickness or the viscosity of the two liquid. So therefore, you could imagine that the hot honey will be much runnier or thinner compared to the cold honey. Okay, if you don't trust me, you can go ahead and do that experiment yourself at home. But anyway, that indicates that hot liquids will be less viscous. Okay, will be much easier for it to flow. Okay, and that applies. That same concept applies to magma as well. Hotter magmas will be less viscous, will be much easier for it to flow. Okay, so therefore low viscosity means high temperature magma, high viscosity means low temperature magma. Oh, by the way, I think I'm covering the video, so let me get rid of my video really quick. I'm sorry about this. There you go. All right, you should still be able to hear my voice, I believe. But anyway, so the next one is the next factor that controls magma viscosity is silica content, or the amount of SiO2 right here, the amount of silicate within the magma. The rule goes like this: higher silica content, it will cause the magma to be high in viscosity, whereas the other way around will apply. Low silica content means low viscosity. Okay, so if you have a bunch of silica within the magma, which means if it's more falsic, it has lower temperature, and consequently the viscosity of magma will be higher. Okay, and the other way around applies to mafic magma. So for example, if you have mafic magma right here, it means that it has much higher temperature than felsic magma, and the higher temperature will cause the magma to be low in viscosity. So please remember the relationship between these three factors right here, between the viscosity, the temperature of magma, as well as the composition of magma. All right, this is just again to remind you that there are four magma composition, as I mentioned before. The last but not least is the dissolved gas or volatiles. So that is the fancy term for volatiles. By the way, where is my video now? Oh, there you go. There you go. I'm back. So the dissolved gas or volatiles, they also have some unique relationship with the magma viscosity, which could also affect the eruption style. So the reason for that is because gas content increases magma mobility, and this is another thing that we need to be aware of, is that gases, when they are inside the ground, there's a lot of pressure that actually keep it in a much smaller volume, but as it travels towards the surface, these gases will expand in volume, and that's something that could cause, violent eruptions. Okay, and the high viscosity magma, which is the thick magma, could also trap more gas a lot better than low viscosity magma, and that would also cause more violent eruption to occur. Okay, and these gases, the dissolved gases, they typically consist of H2O or water vapor, as well as this guy right here. Ooh, what happened there? But anyway, carbon dioxide, okay, CO2. All right, there you go. I think that's it for this video, and I will see you again in the next video. Okay, bye bye now.